So in our next example, we had beryllium hydroxide in a neutralization reaction with phosphoric acid. So reactants are beryllium hydroxide, that's our base, and phosphoric acid. Again, looking at phosphoric acid, you should identify, if you want to talk about the phosphate ion, you should go and find phosphate and see that it's PO4 with a charge of 3-. So balanced against the H+ that we need to give us an acid, we're going to have H3PO4. And then we can look at beryllium hydroxide and see that the beryllium ion, Be, has a 2+ charge. Given hydroxide's known -1 charge, we're going to need 2 hydroxides to balance the beryllium. So we're going to have BeOH2. All right, so those are our reactants, and we can start to think about our products. Very, very similar to the last question. This is a neutralization reaction. It is a double replacement reaction. So we're going to see partners swap from our reactants to our products. Specifically, we're going to see the H+ and the Be swap. So we're going to end up with hydrogen hydroxide and beryllium phosphate. Think about our products. We have hydrogen hydroxide, and we have beryllium phosphate. I'm rushing through the spelling here, so if I'm spelling something wrong, I apologize, but I'm not thinking too much about it as I go. Okay, hydrogen hydroxide. We're going to see this one a million times. Hydrogen is H+, hydroxide is OH-. Together, they are HOH. That is to say, H2O. Beryllium phosphate, though, is a bit of an annoying one. Beryllium has that 2+ charge, while the phosphate ion, PO4, has a 3- charge. So to get these things to balance, we need to double up on our beryllium. Sorry, we need to triple up on our beryllium, I should say. And double up on our phosphate. In that case, I've got 2, 2, and 2, a total of 6+ from my berylliums, and -3 and -3, a total of 6- from my phosphates. So altogether, I have Be3PO4 2. Lovely bit of a mess there. But I've fully identified all of my products and all of my reactants, and now I can write my chemical formula. I can write that BeOH2, beryllium hydroxide, and H3PO4, phosphoric acid, are reacting. And I'm getting Be3PO4 2, beryllium phosphate, and water. If you think about how to balance this, I can maybe, first of all, take a look at the fact that I've got 3 beryllium here, and put a 3 here, so I get 3 beryllium here. I might also take a look at the fact that I have 2 phosphate here, and so put 2 here to get 2 phosphate here. At that point, I can check to see that everything else balances if I put the correct number in front of my H2O, and in fact it does. So going through it all here, I've got 3 groups of 2 oxygen here, 6 oxygen. And then I've got 3 groups of 2 hydrogen, plus another 2 groups of 3 hydrogen, so a total of 12 hydrogen on this side. And if I give myself 6 water, then I end up with 12 hydrogen and 6 oxygen on this side. So that is my fully balanced neutralization reaction between beryllium hydroxide and phosphoric acid. Moving on. C tells me that hypochlorous acid attacks iron, resulting in a salt which includes iron 2. Iron Okay, so I have, in this case, my reactants as hypochlorous acid and iron. Well, iron's super easy. I'm talking about elemental iron here, iron metal. So it's just Fe. Hypochlorous acid is a bit tougher. If I'm looking for hypochlorous acid, I need to find the hypochlorite ion, which is the ClO ion with a -1 charge. And let's make it an acid. We'll balance with H+, and we will get HClO. Okay, then I need to figure out my products. And to do that, I should note that this is an example of a reaction where an acid attacks a metal. So it's going to make H2 as a product. Or note that this is a single replacement reaction. So I can think about the Fe swapping places with the H. And what I should come to a conclusion is that my products are hydrogen gas and iron chloride. Now, I gave you one necessary piece of information in the question there. I told you specifically that this was going to be iron 2 chloride. If I didn't tell you that, you actually wouldn't be able to complete this question. But given that, you know hydrogen gas is H2. You know that you have iron 2, so iron with a 2+ charge. And you know that chlorite is Cl, oh, sorry, it's hypochlorite, isn't it? Wow, hypochlorite. Sorry about that. You know that hypochlorite is ClO minus. So to balance those out, you're going to need 2 groups of the ClO minus, and you're going to get FeClO2. Okay, so now I know my reactants, I know my products, I can write out this complete reaction. I can write out HClO, my acid, reacting with my iron metal to produce FeClO2 and my H2 gas. Balancing here is pretty straightforward. I need 2 of the chlorates, or hypochlorites, because I have 2 of the hypochlorites here, and then everything else actually balances just fine. 2 hydrogen, 2 hydrogen, 1 iron, 1. So at that point, I am done and happy. All right, on to the next guy. This one says oxalic acid attacks copper, resulting in the salt of copper 1 ions. So my reactants are oxalic acid and metallic copper. Of course, copper is just Cu. Don't need anything fancy there. But for oxalic acid, I can look up and find my oxalate ion. And oxalate is, well, you probably just find it C2O4, which is totally fine, with a 2- charge. If you found it in another form, like maybe OOCCOO, that works too. In either case, we're going to balance it with H+. So what we're actually going to end up with here is H2C2O4. Much like the previous question, this is a single replacement reaction where an acid is attacking a metal. So we're going to swap partners in a single replacement and create hydrogen gas, which means that my products are hydrogen gas and copper oxalate. specifically, like the question says, copper 1 oxalate. You need that information because you wouldn't be able to guess which form copper took without it. Hydrogen gas is, of course, H2. I told you that we were dealing with copper 1. Oxalate is C2O4 with a 2- charge. So when I balance that against copper, I get Cu2, C2O4. And I've identified all my products and all my reactants. So I'm ready to balance a reaction. And I can write that H2C2O4 plus copper gives me Cu2C2O4 plus H2 gas. Almost everything comes pre-balanced except the copper, and a quick 2 here will deal with that. Right. The next one I put in as a bit of a curiosity. The actual balancing isn't that tough. The situation that I have is another acid attacking a metal here. But in this case, the acid is actually water. And in some situations, including this one, water will behave as a very mild acid. So in this case, my reactants are going to be water. But I should really think about the water here as hydrogen hydroxide. Just to kind of like keep things straight in my head when it comes to the replacement reaction that's going to happen. And then sodium, which is of course just Na. So my replacement reaction is going to be replacing the positive ion in water, the H+, with the sodium. So the products that I get out of this are going to be sodium hydroxide and then the hydrogen gas that I always get out of these kinds of things. Sodium hydroxide, we talked about it so many times, I'm not going to bother figuring out that it's NaOH, and hydrogen gas is just H2. So when I go to write out my full reaction here, I have that H2O plus Na gives NaOH plus H2. We've seen a balancing situation like this one before. In order to make it work, we do this. 2 sodium balances 2 sodium. 2 oxygen balances 2 oxygen. A total of 4 hydrogen here balances a total of 4 hydrogen, 2 from here and 2 from here. So that's how this thing works overall. Okay, super quickly, because I'm running out of time for a YouTube video, let me take a look at F. F was actually something very similar to what we discussed earlier in the day. So hydrofluoric acid, HF, is added to the product in E, NaOH. And I'm going to get another neutralization reaction here. I'm going to get NaF and H2O. Okay, so I just wanted to get that one on the board. Hopefully, that's all well and good. This video is almost exactly 15 minutes, so I'm going to cut it there. I will see you tomorrow.